is 7.3, example 2. We have the integral of x over the root of x squared plus 4. Okay, usual thing is, can I just do regular substitution, or am I given this integral? Probably not just given it straight up, but look at your formula sheet. Think about it a little bit before you launch into trig substitution. Trig substitution is definitely an option because I got a root that is of the form with an expression here and under it that is on the formula sheet. So, that's a possibility, but can we do it another way? So for substitution, usually it's the inside of the composite function. So I'm just going to explore that. It's not always the case. So x squared plus 4, this looks promising because my du is 2x dx, and I got an x times dx on the top, which is something I can correct for here. I want to do it this way, divide by 2. So this is actually looking really good. And I'm just rewriting the integral here to start identifying the parts. That what we've noticed is that x times dx can be represented by du over 2. So that's taken care of in terms of u. And then down low, we would have the square root of u. So we actually can write this integral all in terms of u. We have 1 over root u, and then we have times du over 2. So now, can you find that integral? And the answer is yes, it's easy. So this is going to work now. We're just going to go do it. Pull out the 1/2, that's not a problem. Whenever you have a root or a power down low, you have to convert it to what it would be as a power overall, or on top. So u to the negative 1/2 du. So now all you have to do is evaluate that easy integral with like the power rule for integrals. Add 1, you get 1/2, put that reciprocal out front for that new power, and we just did it. Now, just plug in your u. It was x squared plus 4. You got the root of that, square root of that, plus c, and you're done. It turns out that this was a relatively easy substitution problem. But note that it was of the form that we had on the trig substitution sheet. And you can do it that way. So that's what this work is down below. And let's compare for a second the difference. Here's all the work for the trig substitution method, which will work if you do it properly. But it's a lot more work, more complicated than just the substitution we did. But again, we learned the trig substitution technique because sometimes an integral of this form with a root and the a squared plus, or the x squared plus a squared or similar is just not possible otherwise. Moral of the story, if substitution applies to a trig substitution looking integral, do it because it's way shorter and less complicated.